Okay, so in part three of this video, we're going to be writing quadratic functions given a graph. So when we have a graph, we can create a quadratic function so that we have an idea when we're using inputs and outputs and where they should be located on the graph. So let's start by saying we can determine a function, not just a function, but the rule for a parabola. I'm going to underline that because that's the graph that we are creating the rule for, with its vertex at the origin, meaning 0, 0. So that's important. So the steps that we're going to take to writing the quadratic function for the given parabola, this will only apply to when the vertex is at the origin. We'll go over how to write a quadratic function when the vertex is not at the origin, but we're going to start with the parent function. So basically the basics of writing a function given a parabola whose vertex is at the origin. So let's start by taking a look at our example. So let's write the rule for the quadratic function shown on the graph. And what I'm going to create is a list of steps that you will take when approaching this. So the first step is, let's just use, let's say, any point on that parabola. So use any point. Okay, and that point will be 2, 2. So we're going to use 2, 2. Okay, so that's the first step. Decide which point you're going to use. The second step is start with the functional form, meaning the parent functional form. So let's say start with functional, say form. And that would look something like this. G of x equals a times x squared. Noticing that this is essentially the parent function. Yes, I'm using g of x. I could have used f of x, but I'm not using that because I'm implying that this is something, a different function outside the parent function, but it really doesn't matter which letter I use here. Just kind of keeping it standard, I'm using g of x. Okay, so that's the first step. Second step. Now the third step is to replace x and g of x with the points. So let's say replace x and g of x with, let's say, point values. Okay, meaning that if this is my x and this is 2 is my y, I could also say that 2 is my g of x. Because remember that this output of g of x is also your y. So if we are replacing that within the functional form, it becomes 2 for my output equals a times 2 squared. I know these are the same numbers, so it's kind of it might take a second to associate which ones get substituted into which, but in the next example we'll use different values so more specifically what to replace. Okay, so the next step after that is just to evaluate x squared and basically solve for a. So let's say evaluate x squared. So I'll show that step, meaning let's square that 2, so it becomes 2 equals 4a. And I'm just writing all the steps from beginning to end. Now let's divide both sides by 4 to get a by itself, so divide both sides by 4 to isolate a. When I do that, dividing both sides by 4, I get a equals 2 over 4, which is a equals 1/2. Okay, actually let me write that underneath. Oops. A equals 1/2. Okay, and now the final step is just write the function rule. So let's say write function rule, and that, I'm just going to move this down a little bit. Oh, didn't do that. There we go. And that function rule would be g of x. And since we just solved for a, I know what a is. I'll say 1/2. And I leave it as x squared because this is the rule. This is the function for that parabola to the left. Again, what we do is we take a point from our parabola. We start with the general functional form. We substitute that point into that general function form for our x and our y, or meaning our g of x. Then we go ahead and we solve for a, and then we substitute that a back in, and that becomes our function for that parabola. Note before moving on to the second example is that notice that our a, the 1/2, that is positive, which is why our graph opens up. Also notice that our a, 1/2, is a number that's between 0 and 1, which is why this parabola looks like it's a little bit compressed compared to the parent function. So those are some things to note to make sure you are doing it correctly and you're creating the right rule. So make sure it also makes sense with your parabola. All right, let's take a look at the second example. So now I want to, let's say, oops, let's get that out of there. Let's go ahead and write the function rule for this. This time I'm not going to list out the steps. I'm just going to show you the order of it without having to write out the words for the steps. So the first thing I want to do is use a point. They kind of already give us a point down here, -2 and -8. So let's use that. So we're going to use -2, comma, -8. Okay, I'm going to write my general rule, which is g of x equals a x squared. Now I'm going to substitute in those values. This is my x, this is my g of x. So I'm going to substitute those values into that function. So g of x becomes -8. A doesn't change because that's what we're solving for. And x becomes -2, and we'll square that. Okay, so let's go ahead and evaluate. We have -8 equals a times -2 squared, and careful here, that is +4. I'm just going to rewrite it as -8 equals 4a. From here, I'm going to divide 4 to both sides to isolate the a. I get -8 over 4. And to simplify that, I get a equals -2. So I just solved for a, and that's exactly what I needed to write the rule for this parabola. And I'm just going to substitute that in over here. So I have g of x equals -2x squared. So let's take a look at this function. It is a negative, which is why my parabola opens down. Notice that it is 2, it is a 2, Not even looking at the negative, it is 2, which is why my parabola looks a little bit more stretched. So as this 2 goes higher and higher, if that number was like a -4, -8, -10, my parabola would continue to be stretched down as that digit gets closer to 0. Say it was -0.5, it would still open down, but it would be more compressed. So yes, it does make sense in terms of my parabola.